Now the topic is iterative version of merge sort. This is two-way merge sort. Two-way merge sort can be implemented iteratively also, recursively also. So first we will learn iterative version. So for explaining merge sort, I have already taken an example array. So let us see the problem. I have an array containing list of 8 elements. One list of 8 elements, and we have to sort them. I'll repeat the problem statement. There is an array containing one list of 8 elements. We have to sort it. Now to apply merge sort, we change the statement. We say that there is an array containing 8 lists. 8 lists. How? See, this 8 itself is one list. 3 is one list. 7 is another list. 4 is another list. 9 is another list. 2 is. So like this we say that each element is a list. So now I'll repeat the statement. There is an array containing 8 lists where each list contains one element. Problem statement is changed. Now you tell me, if a list is having just one element, is it sorted or not? Yes. If you take just this element as one list, it is sorted. This element as a list, it is sorted. 7 sorted, 4 sorted. So each list is sorted. So when they are sorted, we can directly merge them, and merging gives sorted result. Yes. So now the task is we have to merge 8 lists. So how to merge 8 lists? So two-way merging means we'll pick up 2 lists at a time and merge them. So let us start. So first we will merge these 2 lists. This list is having one element 8, this list is having one element 3. So we will merge these 2 lists and make it as a single list. So result will be 3 is smaller, 8 is greater, so we get 2 elements, and this is new merged list. So this is sorted. Then we select next pair of list. So we have 2 lists now. One is having 7, one is having 4. Merge these 2. Result is 4, 7 because 4 is smaller. Now this is sorted. Then we select next pair. 9 and 2, when you merge, it will become 2 and 9 because 2 is smaller, 2 comes first. Now we'll merge this pair of list. So 5 is smaller, 5 comes first, then 6. So this is merged. So we got 4 lists now. Out of 8 lists, when we have merged 4 pairs, then we got 4 lists. Now if you observe, earlier what was the size of list? Just one element. Now what is the size of list? 2 elements each. 2 elements each. Now again we have to continue. We have to continue merging. Now again go through this entire array by merging lists. So what are those lists? Merge these 2 lists of 2 elements each. The result will be smallest number is 3, then 4, then 7 and 8. We got one list of 8 elements. Then merge these 2 lists. 2 is the smallest, then 5, then 6, then 9. So we got another list. Now 4 lists we have merged by taking pair at a time. So we got 2 lists. Now we have to merge these. Size was 1 element, size was 2 element, now size is 4 element. So size is getting multiplied by 2. Size of the list is growing by 2. Now we have to merge these 2. Merge these 2. 2 is smaller, then 3 is next, then 4 is next, then 5 is smaller. Then compare these 2, so 6 comes next. Then compare these 2, 7 comes next. Then 8 comes, then 9. That's all. This is sorted. So this is how iterative version works. For 8 elements, how many passes we have performed? So pass means we have gone through the entire list at once. So this we have gone through and we got this result. So this is first pass. Result of first pass. Then this is the result of second pass. Then this is the result of third pass. So we have performed only 3 passes and we got the result. So total how many elements were there? Total 8 elements were there. So for that we have performed 3 passes. In this pass we were merging one element. So we were merging 2 lists. So the size was 2. Then next time it was 2 elements, so together the size was 4. The next time 4 elements, so together the size was 8. So let us do analysis. See, this is an iterative version and it is having passes. Passes means we are going through the entire list at once, not partially. At once we are going through it. If it is recursive, it will not have passes. It is iterative, so that's why it's having passes. So in one pass, how many elements are merged? So in one pass, what is the work done? We are doing nothing but merging the elements. So total, how many elements are merged? N elements are merged. Then again, from this, how many elements are merged here? From there to here, N elements are merged. Then again, from there to here, how many elements are merged? N elements are merged. So this is done how many times? So if you turn this upside down, you can see it as a tree. See, this is the root, left child, right child, and its left child, right child, and these are left and right child of this one, and these are the left and right child of these nodes. So it looks like a tree. So it is same as height of a tree. So height of a tree is nothing but log n. So this is done for how many times? Log n times. Or else there are total 8 elements. 8. Log 8 base 2 is how much? 3. So it is done for 3 times. 3 passes are required. So that's how it is log n. So total time is n, that is done for log n times. So the time complexity is order of n log n. So the time complexity of iterative version of two-way merge sort is n log n. Now let us look at algorithm or a function for iterative version of merge sort. So I will write on the function, then I will explain you. So here is a iterative version of merge sort. It is taking array as a parameter and n, that is number of elements. So here number of elements are 8. So this is 8. Then this for loop is for passes. So how many passes we need for 8 elements? 3 passes. That is log n passes. So here I have taken p assigned 2 and the p is getting multiplied by 2 and reach up to n. So if I write p values, first time p will be 2, then the p is getting multiplied by 2. So next time p becomes 4, then again multiplied by 2, so p becomes 8, and it will continue as long as it is less than equal to n. So now it is equal to n, so it will continue. So total 3 passes it will perform. P will take 3 values. So when the first pass is performed on the original list, p value will be 2. The next pass, p value will be 4. The next pass, p value will be 8. So what is this? I will explain you. If I take from the last list, p value is 8 means total 8 elements are merged. In this 2 lists are there. One is with 4 elements, the other one is also with 4 elements. So total 8 elements are merged. That's why p value is 8. If you remember merge function or algorithm that we have seen in the previous video, it takes low, mid and high of a single array and merge them with the help of auxiliary array. If you have not seen previous video, just watch previous video upon merging. There I have explained you how 2 lists in the same array can be merged. So for that, low, mid and high, 3 values are required. So when p is 8, low should be this one and this should be mid and this should be high. So it will merge a list from low to mid and second list is from mid plus 1 to high. So that's how for 8 it works perfectly within a span. This is mid. Now when this is 4, so this is low, this is mid and this is high. So just 2 lists are merged. Again it has to be continued for this one. For this one also it should be continued. Again this is low, this is mid and this is high, where the total elements are 4. So similarly, when p is 2, then more than one pair of lists has to be merged. So for that I have taken one more for loop I. So I is taking a span of 2 lists, then again 2 lists, right? So it is moving by p. See, moving by p. So using I we calculate low, high and mid. So as we have to merge more than one pair of lists, so for that we have this iteration I. So if I show it on first list, first time I is here, so these 2 elements are merged. Next time I will be here, then these two elements will be merged. Next time I will be here, then these two elements will be merged. Next I will be here and these two elements will be merged. And each time this is low, this is high, and this is mid. This is low and this is high, and this will be mid. This is low and this is high, and this will be mid. So that's how all our calculated and merged function is called. So if you want to understand it by taking values, then you have to substitute, then you have to prepare a table and understand how these values are changing. Then one last thing in this function. I have taken exactly 8 elements. So log 8 base 2 is 3. So I get exact answer. If these are not 8 elements, so if suppose this is 9, then one extra element will be there. Suppose I will take one more element 1 here. That will not be paired with anyone, it is not merged. Then same 1 carry on here. Again this 2, this is left over. Then again 1 carried on here. So this 2 will be merged. Then again 1 is left over. Then it comes as it is. Then this list should be merged with this 1. So one more pass has to be performed. So for that, this merge is there. So when you have odd number of elements in a list, or the list size is not in powers of 2, then some elements will be left over. So for merging them, this function is there. So that's all about iterative version of merge sort, which takes n log n time. I will write the program and run it and show you.